Okay, so more with arrays. Like I said, we're gonna get through the first 3 pages or so today. Number 1 says, write a method for the FHS array class that will determine if 2 arrays of the same type, integers for this example, are equal. Example of the method call. So it makes an FHS array object, FHS1 they're calling it, and the codes declare and fill array A and B are not shown, but they're making A and B are some arrays. And I put this arrays equal method that we're going to write inside an if statement. So if you see a method inside an if statement, then it's going to have to return what type of variable, true or false, which is a Boolean, okay? So that's how you know right away that arrays equal is going to be a public Boolean, for sure. All right. So before we get into this, here's some background notes up here. What does it mean for 2 arrays to be equal? What would it mean for you if I said array A and array B are the same? Yeah. The sum of all the slots are the same? Well, that's one way to kind of check it, but if I did like 1 plus 2 plus 3 or 3 plus 2 plus 1, they're not really exactly the same because they're in different order. What were you saying, Carly? Yeah, all the slots, the individual slots are the same. Okay, so normally when I check if 2 variables are equal, we just check if they're equal. So can't we say A equals B? So if one array is called A and one array is called B, anyone know what's wrong with that? Why I couldn't just say is A equal B? Any idea? That'd be A.length, B.length. But you're kind of on the right track. A equals B isn't actually checking the individual slots. Remember what the actual variable A and the actual variable B is storing when you're talking about arrays? That's what Adam said. It's not really the length of it. Yeah. It doesn't see the numbers inside the slots are the same, right? So that's why it doesn't work. But remember, when I make an array A, if I said system.out.print A, remember when we first did arrays, I did that, and I showed you what came up, and it was a bunch of random letters. That was that memory location thing. So, right, where it's saved. So A and B are actually a memory address. They're called pointers, which you've learned more about in AP Comp Sci, but it's a memory address pointing to where the actual values are stored. So if array A is 2, 4, 6, and 8, and array B is also 2, 4, 6, and 8, but stored in a different spot, we'd want to say that these 2 arrays are equal. So A is holding the memory address of where the array is stored. And this kind of gets into a discussion that's bigger than what we need to worry about for Comp Sci 2, but it's all talking about primitive variables versus objects. So primitive variables are the types of variables that you're used to dealing with, like ints or chars or booleans. And in those cases, equals equals is okay. We can check if two chars are the same by checking equals equals, or ints, or booleans, or doubles, or so I should put dot 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 here. It's not just those three. Doubles works. Objects are a little trickier. So arrays are obviously objects. Another object that you use a lot are strings. I think Eclipse might be updated now that you can check if two strings are equals by doing equals equals, but it used to be you'd have to use a whole nother method to check it. Random objects. I'm not just saying random like that. The actual random objects is what I mean. So like the random class that some of you use to get random numbers, or the math class. Those are all objects. And with these, equals equals is not okay. All right, so I think you all get what's going on, but just let me show you one demo code real quick before we go on. Here's an array A that I've made. It's 1, 2, 3, 4, 5. Here's an array B that I've made, the exact same values. So for all intents and purposes, A and B are equal, and I want them to be equal. Then I make array C, and I set it just equal to A. I'm going to print out A, B, and C, then print out what happens when I do A equals equals B and A equals equals C. When we run this, here's those crazy memory locations. You can see that A and B are two totally different memory locations. C is the same as A, and that's because I set it equal to the A memory location right here. So those are literally the exact same thing. A equals B comes up false because these two memory locations aren't the same. A equals C comes up true because these two memory locations are the same. Okay, so that's why you can't just do equals equals to check if two arrays are the same. Questions yet? Okay. So we got to come up with another way to do it. Here's how to do it. So first we've got public Boolean. And it's public Boolean. It's called up here arrays equal. You can see from my sample code, I'm sending it A and B, and both A and B are arrays. So int bracket bracket A, comma int bracket bracket B. So in this case, the precondition is just two integer arrays. And the post condition returns whether or not arrays are equal. And what we're going to do is actually, it's kind of like in math. In higher level math, there's things called proofs of contradiction. You assume that they are true or they are equal unless you can find something that contradicts that. So we're going to try to prove it wrong here. We're going to try to prove that it's not equal. And if we can't do that, that means they must be equal. So we know that things stored in every spot have to be the same. Before I even check that, what also has to be true about these two arrays if they're going to be equal? Same length. Good. So first thing I'm going to start with is if A dot length does not equal B dot length, then they're definitely not equal. I can definitely return false. Now, why could I not just say if A dot length equals B dot length, return true? Right, it means the lengths are the same, it doesn't mean the numbers are. That's why it's easier to prove it wrong first, and if we can't prove it wrong, we'll say it is the same. So if the lengths aren't the same, it's definitely not equal, so that's false. So else I've got to go through and check space by space to see if they're equal or not. So if I'm going through an array, everyone knows I'm using for loop. For I want to start at the beginning of the array, so we want I to start at 0. As long as I is less than, should I use A dot length or B dot length? Either one doesn't matter. If I'm in this spot, then they're both equal. So A dot length, I plus plus. And I can't say if A bracket I equals B bracket I return true, because that just means the first space is going to be the same. So instead I have to say if A bracket I is not equal to B bracket I, return false. So if I find a spot that's not equal to the corresponding spot in array B, they're definitely not equal, return false, we're done. If this isn't hit, I don't necessarily want to say else return true, that just means still the first spot is the same. So if I just go through that for loop, if this if never happens, so if two spots are never not equal to each other and we never return false, then the only other option is they must be totally the same. So once we end this else down here, we can just say return true. So if I get to this point, that means they're equal. Questions yet? Okay, page 2. Number 2 says the sum of any two consecutive numbers in a credit card can exceed 13 no more than 2 times in a valid credit card number. Write a method that will accept or deny a given credit card number. The credit card number is stored as an array of 16 single digits. So here's your credit card. As I go through it, 2 plus 4, that's not, if it's not, doesn't exceed 13, it's not a problem. So 2 and 4 is 6, that's fine. 4 and 8 is 12, that's fine. Here's one spot where two numbers next to each other exceed 13. Keep going, keep going. Next spot where it comes up is right here. 7 and 8 are 15. Never happens again. It only exceeded 13 2 times. It could be 2 times or less and be okay, so it's a valid credit card number. I don't know if this is a real thing or not, but credit card companies have different security measures to see if people are trying to forge credit cards. So this could be one type of measure. It's something subtle that people might not know, but it's a way to check. So here's an example call. We've got credit card C1 equals new credit card. We're making an array to hold the card number. There's a method that reads the card number, probably reads it in from a file or something like that. We have an if statement. If the credit card's valid, then you charge the card a certain amount. And if it's not, we get a message saying credit card's invalid, and the person gets arrested. So, credit card says, what is credit card? Credit card C1 equals new credit card. If you were making this program, what would you say credit card is? It's a class that you made. Good. So it's a credit card class. C1, I don't know if you know the technical word for this. We've talked about it a few times. C1 is an instance of the credit card class. We call that a credit card object. So that's what an object is. It's an instance of a class. So C1 is the object or instance of credit card class. You know that basically just gets access to all the methods that are in there. Okay, now how many different methods in this credit card class do you see just from the code above? How many? 3. What's the first one you see? Read credit card. So it wants lists and describe their purpose. You're kind of guessing their purpose based off of what they're called. So read credit card is pretty straightforward. It stores card number into an array. Because card num is an array that's getting sent over. Card num into array. What's the next method you see? Credit card valid. What do you think that's going to do? Right, check to see if that rule about adjacent digits not exceeding 13 more than twice is held or not. So I'm just going to say determines if card number is valid. And then the last one you see is charge. Since I'm sending it the card number and a certain dollar amount, you can probably guess that this charges amount to credit card. All right, now you might not know how to write all of these. Read credit card, you could probably figure out. It'd be just some kind of SC dot next in getting stored into the array. Credit card valid, we're going to write in a second. Charge, you'd probably have to somehow attach that amount to this card number and export it to a file, which you haven't done yet this year. So that we wouldn't know how to write right now, but we can write credit card valid. So credit card valid is going to have to check for those adjacent sums adding to no more than 13. So based off of where that is in here, it's going to be a public what? Boolean again, because it's in an if statement. Ifs are trues or false. So we got public, Boolean, credit card valid. Check to see what it sent. Looks like it's only card num, which is the array. So I'm just going to say int bracket bracket A, so I don't have to write card num every time. For our precondition, we have an int array. Representing credit card number. Post condition. Returns true. If valid. And that means consecutive digits. Add to no more, or add to, let's say add to greater than 13 2 times or less. So maybe it'll never add to more than 13, that's still valid. Maybe it'll add 1 time to more than 13, that's still valid. 2 times is okay too, it just can't be any more than 2 times. Okay, so obviously I'm going to have to go through the array counting up, consecutive numbers. What else am I going to need if I'm going to keep track of how many I add to more than 13? Check. Right, accumulated. So right away we start with int count. Initially start at 0. And then here's the for loop that goes through the array like always. So for int I equals 0, I is less than a dot length, I plus plus. Need to check if the sum of the current spot and the spot next to it is more than 13, because then I want to add 1 to the count. So how would I do that? I'd say if a bracket I plus a bracket I plus 1 is what? Greater than 13. What do I want to do in that case? Count plus equals 1. So it's not necessarily invalid yet. If it's not greater than 13, I don't care about it. It's fine. I can just ignore it. And there's one more thing, but before we go on, we just did something kind of dangerous that you got to watch out for, and this is going to come up a lot. I can't remember if it's in the next test it comes up or if it comes up in future programs that we do. But what we just did right here is really dangerous. When you start doing I plus 1, for the index, if you start messing with the index, you're potentially going to go out of bounds. Okay, so we set up this for loop so that I only go from 0 to the last space. But if I start doing this +1 stuff, then I might get to the last space and then try to access a space that doesn't exist. Yep. Exactly. You have to do a.length -1. So what you need to do, as soon as you start doing +1, or if you did -1, you'd have to affect it too, you've got to compensate in your for loop. So if I have +1 here, I got to put -1 here so that it definitely won't go out of bounds. So anytime you mess with an index value, think about that and make sure you're not going out of bounds. Okay, so I've done this now. I know how many times the consecutive values add to more than 13. The last thing I have to do is either return a true or false. And there's two ways to do this. The fastest way, not the easiest, but the fastest way would be to say return count less than or equal to 2. And that looks weird to a lot of people, but count less than or equal to 2 is a Boolean statement. If it is less than or equal to 2, then it returns true. If it's not less than or equal to 2, then it returns false. If you really hate that, you could always say if count is less than or equal to 2, return true. That means it's valid. Else, return false. Obviously, the first one I did is a little bit more compact and probably nicer to programmers, but to someone who's not really familiar with what that's actually meaning, that would do the same thing, and I would never take off for that. Any questions? Okay. The last part of this packet, so question number 3 takes us through the entire end of the packet, I'm pretty sure. I think I'm going to stop after this page, but this page is going to take a little planning to get through. So number 3 says, a researcher wishes to calculate some statistical properties for a collection of data integers. The data values are represented by the array tally. And this is the array down there. The indices of the array represent the possible values of the actual data values. So the data values could be 0 through 15. Each array location contains the frequency or number of occurrences of the value in its corresponding index. So it's kind of like histogram. It's telling you how many times each of these numbers occur. It says in the example below, tally bracket 4 is 10, which means that the value 4 comes up 10 times in your data. Tally bracket 8 is 0, which means there's never an 8 that shows up. So maybe people are asking, surveying a group and saying, how many hours of TV do you watch a week? 10 people watch 4 hours a week. 10 people watch 11 hours a week. 3 people watch 12 hours a week. No one watches 14 hours a week. So that's what this is saying. So I think, keep in mind while we're writing this, that this is the actual data value. So this isn't in your packet, but this literally means there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 2s, 5 3s, etc. That corresponds to the numbers that are in here. Except for some reason, this number is different than what yours is. Everyone with me, though? You get that? Make sense? You know what it is? That'll help later on. All right, so the first thing we're going to do, you will write a method, calculate modes. Calculate modes returns an array containing the mode or modes found in the tally array up here. The length of the returned array is equal to the number of modes. All right, so I know some of you are just starting to get into statistics and algebra 2, but you've all heard of mode before. I have guesses on those. What's mode mean? Most often. Most often, right? So I want to figure out what numbers occur most often here. So looking here, what would the modes be? How many modes would there be, first off? There's 3, and what are they? 10 is the highest number. That corresponds with the values 2, 5, or 2, 4, and 11. So that makes more sense also if you look at this. So which ones occur most often? There's the most 2s, the most 4s, the most 11s. So those are the modes. Okay, so the problem here is if I want to return what the mode is, without knowing what this array looks like, I might have 1 answer, I might have 3 answers, I might have 4 answers, and we've never returned more than one thing in a method ever before. You can only return one thing through a method. You can't return multiple values. Unless you return an array, then you can return everything that's stored in that array. Okay, so that's what we're going to end up doing. We're going to return an array which will be long enough to hold all the modes that there are. I don't want to just make an array of length 16 in case there's 16 modes. I want the array to be as long as the number of modes that there actually are. Okay. So just reading through this quick, it's mostly what I told you already. Mode is defined as a value that occurs with maximal frequency. There's more than one such value. Each is considered a mode. So 2, 4, and 11, they each occur 10 times for the modes. This is one of those methods things that you wrote in your last test. The following method, find max, is a member of the stats class and is available for your use. It returns the maximum value in the array nums. So using the example array, if I sent this tally array to find max, it would return me 10, because that's the biggest number that's actually stored in the array. So there's what the method looks like. It's written. You don't need to know how it's written, but it is written. And it specifically says do not write the body of this method. In writing calculate modes, you can call find max as specified above if you need it. So that's like your last test where you wrote that first method that was like find lowest or something, and you had to subtract off the lowest. You know what I'm talking about, where you like referred back to it and you got the lowest, subtracted it off. That's what I'm saying here. You can use this method to your advantage. All right, we're going to complete the method, calculate modes on the next page. We're going to do that tomorrow, but we're going to figure out the plan today. So if I'm faced with a problem like this, this is kind of like what you do when you have a normal program. So the big idea is we want to outline the major steps. And you could kind of follow this process when you're on a test too, instead of just jumping into the code. So we want to outline major steps before we can write code. So it's like writing a hierarchy chart, especially when these methods are getting more complicated. If you just try to jump in and start doing it, there's things you might not think about that you have to go back to reinsert and erase and change later. So it's just better to kind of plan out first. So naturally, what would you ask yourself? You'd ask, what do we need to do first? Sometimes you might not even think about what you need to do first. You know that if you're going to return an array that holds all the modes, one of the first things we're going to have to do is create the array. So create the array is something we have to do first. And we're going to create the array to hold the modes. So like we said above, in this example, my goal is to have some array that gets returned. And this particular array is going to send me back 2, 4, and 11 because those are the modes. But I can't just create the array without knowing what? How big to make it. But in order to make the array, we need to know how big to make it. But then to know how big to make it, you need to know other stuff. Yep. Yes. And that's called a matrix, which we're doing next week. Just keep going. Yeah. So like right now, these are one-dimensional, but next week we're going to look at things that like essentially are like this, like a chart almost. But that's actually an array within an array that we'll talk about after next test. Okay. So we need to know how big to make this array. What's that based off of? How many modes they are. Okay. What's the mode based off of? How do we know that 2, 4, and 11 are modes? The highest. So the first thing I actually have to do is we need to know how many modes there are. So step 1. Need to know how many modes there are. We said in order to know that, you need to know the highest. How am I going to know what the highest is? That find max method, right? So the first thing we're going to do, we're going to say, so call find max to get what the max frequency is. So for the example that I gave you, once I do step 1, we're going to have that the max frequency is 10. So I'll know that after step 1. Once I know the max frequency is 10, what do I have to do next? Check the array for what? Right, which numbers have 10. So check the array, how many times does 10 occur? So I'm just going to write it as a step. How many times does max frequency occur in array? You can probably think about how you would do that. Most of you know the code that we could go through and figure out how many times 10 happens. So for my example, this comes out to be 3. So now that I know it happens 3 times, now what would I do? Make an array that's that big. So step 3, make an array of length bound from step 2. Okay, so at this step, I would have an array that's got 3 slots in it. 0, 1, 2. And now that I've got the array made, what would I do with that array? Fill it with the numbers that should go in that. So fill array with the modes. And just keep in mind that the numbers that I'm filling correspond to the indices where that 10 is. So like, once I find the 10 is at space 2, I want to fill in the first spot in the array with 2. I want to fill in the second spot with 4, third spot with 11. So for tomorrow when we write this, I'm going to keep a note that the data values that we want equal the indices where max frequency occurs. Okay, so after step 4, I've got 2, 4, and 11 in the array. And then the final step, got everything I need. So the last step of any method is to return it. Return the array. All right, so this is a pretty complicated method. There's a lot going on here. Now that we've got these steps outlined, we can go tomorrow, write out the code for this, and it should be pretty straightforward. None of this is really all that tricky to actually write. All right, so save this. No homework tonight. We'll continue with that tomorrow.